Hey, I just want to let everybody know that this video is not intended to be a video to show you how to repair your Hallicrafters radio. This is for entertainment purposes only. If you choose to take a radio apart and work on it, you do so at your own risk. This radio in particular happens to be a very dangerous, potentially dangerous model of radio. This was made very early on, back when some radios were made with the ability to run off of either AC or DC. In order for that to be able to happen, the radio has to be wired a specific way, which makes it a little bit unique. Over the years, a couple of different things can happen that can cause this to be a very high shock hazard radio. For instance, the non-polarized cord, depending on which way it plugs in, could cause the chassis to become hot. And I don't mean temperature wise, I mean that AC voltage is present, and if you were grounded and touched the chassis, you could be killed. A lot of these old capacitors could be developing leakage current and could also create a highly dangerous situation and shock hazard. During my servicing of this radio, I am running it through my Sencor PR57 PowerRite, which is a variac, but it is also an isolation transformer. Many shortwave radio enthusiasts have been able to modify this radio and install an isolation transformer internally in order to mitigate some of these hazards. Welcome back to the channel. This is a Hallicrafters model S22R receiver. It's pretty darn old. It's in really rough looking shape, but I ended up getting this thing for 10 bucks. It was at the same roadside yard sale that I picked that crate guitar amplifier head that some of you may have seen the videos I did on basically going through that, and then ended up cleaning it up, selling it, and then it actually ended up having a problem that didn't rear its head until after 30 minutes. So it came back to me, but I have since repaired it and it's good to go. So that ended up being a really good deal. So I don't know, you know, this thing just kind of caught my eye. I thought it was kind of cool looking. When I first picked it up, I didn't even know who made it or anything, and then I was able to figure out that's an H right there, and there's an H logo here, and S22R. It's a pretty well-known early shortwave receiver model. So looks like maybe it was somewhere where there was a lot of moisture. I see quite a bit of evidence of rusting on it. It's really a beast. It has what's supposed to be a swing open lid. There's a hinge here, but the hinge is so rusted that this actually wants to not open. So it's pretty bad. And I could spray some like PB Blaster or whatever on that hinge, but I don't want to have that stuff run down inside. So I think what I'm going to do is, let's see. Guess what I'll do is I'll put it up on its side and I'll spray some cleaner, some blaster, PB Blaster penetrant on this hinge and see if I can't get this to move. Oh, I think I'll try this Castle new ion activated thrust penetrating oil. That sounds romantic. It's all in the touch. That stuff doesn't smell too bad. It's better. Good enough. Well, it looks like all the tubes are in there. So for some reason we've got the dial indicator light is just laying in here. Oh, okay, that looks like that. Clips on maybe here. Like that. Oh, look at that. Perfect. I already did my first repair and haven't even plugged in yet. Oh, well, now that's interesting. I don't think you're going to find that on the parts list. That is a mud dauber's nest. So not only was this in someplace damp, but it was probably in like a barn or something, because that's the nasty, large iridescent bluish colored wasp that we have up here in the Northeast, which packs a hell of a wallop when they sting you. Call them mud daubers because they fly to mud puddles and get little bits of mud and bring it back and build these kind of nests. Yeah, that could definitely probably affect tuning. Alright, so here's my plan for this. My plan is not even to think about restoring this pig. The truth is, I have other shortwave receivers, and if I really wanted to fix up a shortwave receiver and use one, I've got better prospects than this. But what I would like to do is I would like to resell this for more than what I paid for it. And I figure if I can maybe just get a little bit of life out of this, that would go a long way towards helping me resell it. So the biggest problem, immediate problem, is the cord, or should I say what's left of the cord that's on here. It is just scary bad. That cord is scary enough looking that I'm not even going to think about trying to plug that in with that cord. Job one, let's find a way to get some power to this that's not going to instantly create smoke. So we've got 6 screws that hold this bottom cover on, and that gives us, well, there's 5 out of the 6 are in there. That gives us access to the underside of the chassis where all the hardwired components are going to be. Interesting, you got all these holes right here, and I can see all of these trimmer capacitors. So there's 12 of them right here. So that's going to be all for doing various alignments, probably on the different bands. Oh, I see this screws here and the remnants of some feet that are long gone. This screw right here does not want to come out, so I'll have to put some upward force on it as I turn it. Oh, and then it just pops right out. Oh, how lovely. Oh my. Oh, I am not liking at all what I'm seeing in here. Yikes. I think this is going to be an exercise in futility. So what I'm seeing in here that's really giving me pause is these capacitors right here. These are all caps, and these are all the type of cap that basically whenever you see an old piece of equipment you're working on, and if you want it to last any amount of time at all after repairing it, you really should go through and replace every single one of these caps that you see, and there is a bunch of them in here. And I just don't have it in me. I just don't have the motivation to take this to that level. So, well, could at least share with you some excitement, right? Or lack of excitement. Let's still think about putting a line cord on this and putting some power to it just for giggles. Well, now I see something that has me kind of perplexed. Now, if I worked on old radios like this all the time, I probably wouldn't be surprised at all by what I'm seeing. But what I'm seeing is that the line cord comes in the back here, and the 2 leads of the line cord go to these fuses. So what's kind of unusual to me is it doesn't make sense to me to have one leg of the AC go through a fuse and then the other leg of the AC go through a fuse. In other words, normally I would expect, well, these 2 wires right here probably go to the primary of the large power transformer. That would make sense. I take that back. They probably go through the AC on-off switch on the front and then eventually go to the power transformer. That makes sense to me. But why have both legs on a fuse? So I'm going to take a guess, because this is not something I'm used to seeing, but I'm going to guess it has something to do with the fact that this thing is so old, it has a non-polarized plug. And I'm guessing it has something to do with the fact that, and on any given day, this might get plugged in one way or the other way. In other words, we've got, on our AC house circuit, we've got the hot and the neutral. So, because this is non-polarized, either one of these could end up being the hot, depending on how you plug it in. And I guess they wanted to make sure that the hot line was fused going to the transformer. I guess that would be in case you had an internal short in the transformer. That would ensure that there was a fuse to blow. Okay, that's my guess as to why they did that. That's my guess, and I'm sticking to it. All right, I got the old wiring off. So all I did was run that through that hole and then tie a knot in it, and that was the strain relief. And then there's the remnants of what looks like a grommet was on there. This was probably originally kind of rubbery and snapped in that hole. It is now turned into a very hard, unforgiving piece that does not want to go back in that hole. So I don't think there's much I can do about that. Yeah, all right, grab a cord out of my junk pile. Well, I had to get kind of unfriendly with it, but I was able to bash that plasticized grommet back into position. Better than nothing. Giving it my patented left-hand twist. Being a southpaw. That a little secret you didn't know about me. Who cares, right? All right. What would really be great right about now is my eyeglasses. Okay, one ratty looking cord from my junk pile installed. Not my best work. Nothing I'm going to be too proud of. Now, for the most dramatic results, I could just plug this directly into the outlet and turn it on and cross my fingers. But I am going to err on the side of caution and use my fresh off of its little repair video, the Sencor PR57 power rate. So this is a Variac. It's going to allow me to bring up the AC voltage slowly while monitoring the AC current draw. So my line voltage down here in the shop is at about 122 volts, nice and healthy. So I'm going to switch this to output mode. This is turned all the way down. I'm going to plug it in, and we're going to switch to the 0 to 1.5 amp ammeter, and I'm going to turn it on. I wouldn't expect anything yet because there's 0 volts going into it. So now I'm going to bring the output up slowly. That's at about 32 volts. Alright, we're up to 60 volts. And I'm not drawing any current, so something is amiss. Alright, so I already knew the fuses were good. It's the first thing I checked before I even changed the line cord. But if I go on the output of the two fuses, these two connections right here, which should go just in a circuit right through the on-off switch to the primary winding of the transformer. It doesn't matter what position I have the switch in. I'm getting infinite resistance, an open circuit. So either the on-off switch is bad or the primary winding of the transformer is open. So if the primary is open, then game over. So let's see. Can't see what's going on with this switch. Well, that's great news. I get right to the back of the switch right here, and I can see that the switch is open. So got a bad power switch. I'm sure this is the least of this thing's troubles, but at least it's something that won't stop us from going forward with our quest for smoke. All right, kids, don't try this at home. I just jumped out that switch with my mini test clip jumpers that I had handy. We're going to go back to, well, I don't have to turn it on because I just basically eliminated that switch altogether. So now, as soon as I power this up, there's going to be voltage going directly to that transformer, or what's left of it. Power on, turn the voltage up a little bit, and we're getting current draw. I have it on output. That's not current draw at all. You moron. Oh, no, there is current draw there. See, the meter went down a little bit. You can't see it. I probably don't have the camera set up to look at the meter. This is where the fun's going to be anyways. Bring the voltage up a little more. Not a heck of a lot going on. Not even up to 1/4 of an amp. Alright, there we are. We're drawing 1/4 of an amp. 55 volts. The front panel light that was just laying in there loosely is actually lit. If you can believe that. I wonder if we've got filaments on those tubes. I really thought I was going to see more action on the underside here. It's not starting to smoke, you know, but nothing yet. That's 70 volts AC. If the filaments light and the tubes start conducting, we should see the amperage start to go up. But it's not. Wait a minute. There's something. That sounds to me like 60 cycle hum, which would indicate a bad filter capacitor, which wouldn't surprise me. Very interesting. I decided to see whether or not this switch is completely gone or not. There's a little hidden set screw right here, and I had to loosen that and then very carefully pry this off so I don't break the knob, because if this ends up being a complete piece of junk, that knob might be worth somebody. I mean, case in point, this one's missing the volume knob. The on knob is the tone knob. It's kind of weird. It's usually on volume, right? So when you turn it on, the volume's all the way down, but nope, not this one. All right. And then I unscrew this nut, and voila! It doesn't want to come off. That is weird. Why is it not working? Oh, are you ready for this one? You know what these stinkers did? They put these controls in from the back side of the chassis. Then they put a retaining nut on to retain the control in the chassis. Then the whole chassis slides in, or actually I guess this whole front cover goes over the front of this thing, and then they put a second set of locking nuts on, which is what fooled me. So I can't just take this washer and this nut off and pop that control out like I thought I could. I have to take all of the knobs off, all of the nuts off, the whole front face off, and then that'll expose the nuts that'll let me get the controls out. And I already warned you guys, I'm just not that motivated. So I will put this back on. Every good radio mechanic uses a ratchet. I think what I'm going to do is I'm going to install a jumper wire across the back of that. That's a little more robust than my little clip-on clip there, so that I can lower this thing down and see if the tubes are all lighting. See, I was wondering why the retaining nut for the AVC switch, which is an automatic volume control circuit, which is kind of like an automatic gain control, the nut's missing, and I was wondering why that switch doesn't just fall out. That's why. This radio's got more hidden nuts than an absent-minded squirrel. Changed my mind again. I just repositioned my jumper wire so I can leave this fairly much original. I was going to put a jumper wire in, but so now I've got my voltage set up back to the 80 volts output, but I got the switch off. So now I'm just going to hit it with the full 80 volts, and we're going to see what happens. I'm curious to see whether or not the filaments all appear to light, although these are not glass cases, so I won't be able to see 1, 2, 3, 4, 5 of these tubes. I won't be able to tell if they're lit, but I will be able to see if this one, this one, this one, and this one. That's interesting. That tube has a cap on the top like an anode with a lead that goes right over to the tuning capacitor, and I'm monitoring the current. Like I said, the panel, oh, there's 2 panel lights here. They're both lit. Whoop-de flippin' do. There's the hum. So what that tells me is that the audio output tube and the audio output stage is working. And once that tube starts to conduct and, you know, heats up and starts to conduct, it's amplifying that 60 cycle hum. send receive switch, so you must have to, so there must have been a matching transmitter that you could buy with this, and then what you would do is you would when you wanted to transmit, you'd flip this switch, and then you'd use the transmitter to transmit your signal. So this would be akin to a standby switch, I guess. Alright, so right down here in the corner is where that big metal canister, round metal canister, is on the top of the chassis. That's the filter capacitor, and it's got multiple sections in it, so there's multiple capacitors inside one assembly. So what I did was I checked the DC voltages on all four of those connections, and I found the one that had the highest DC voltage on it. That would indicate to me that that's probably the first one in the power supply. I'm going to bridge in a cap. This is a 47 microfarad at 450 volt. I have no idea what the value is of that cap, but 47 should make a difference. If the filter cap is the problem, then if I bridge this in, we should see a noticeable decrease in the hum. Of course, I want to make sure I get the polarity right. So this is positive DC voltage. So I'm gonna hook the positive lead of this cap to that connection on the capacitor, and then I'm just going to touch the negative lead to the chassis, which is ground. All right, let's fire it up, and here it comes. All right, now I'm going to bridge in this cap. Alright, interesting. That's not making any difference at all. If you're going from one lead on a cap like that to another one, bridging in caps, you could always make sure you discharge the cap in between, because you might be going from a higher voltage point to another. In other words, that cap may have been charged up to a high level, and then you go to put it on a point that's not supposed to see that much voltage, and the cap dumps its voltage into that circuit and could cause damage. So, alright. Alright, let's try another one. Same thing, same result. Try one more. They're making hardly any difference at all. Well, that's a bummer. Alright, so I poked around on the internet just to see if I could find a schematic, because I was curious how the power supply was on this thing, and lo and behold, the mystery of the two inline fuses on both legs has been solved, and the non-polarized cord. The reason behind this is because this radio was made early enough that it was actually designed to be able to be run on either AC or DC. So because of the way this radio is wired, there's a very high potential for shock, electric shock. I am running this through my Sencor PowerRite PR57, which I had mentioned is a Variac, but it is also an isolation transformer. So it isolates the chassis from the AC line. So that doesn't mean that this is safe now. It's one level of safety that should be taken into account if you choose to work on one of these, which you do so at your own risk. Let me take a moment to show you how dangerous this radio can potentially be. And keep in mind, I've actually got this I've got this plugged into an isolation transformer. I'm going to turn it on. I've got it set at the full rated voltage going in, 120 volts AC. I've got my AC voltmeter. I'm going to touch a ground on the chassis. I'm going to take the other lead, and you're not going to be able to see it, but off camera I'm going to touch it to the case of the electrical outlet, which is the ground for the AC circuit. So you see we've got 30 volts AC present there. flip it around at 36 volts. This is a dangerous radio to be playing around with. Well, I did one last thing before I decided to give up on this, which was I looked at what the B plus level was coming right out of the rectifier tube, and it's seems to be pretty low. I did find a post where somebody said it should be around 120 volts DC coming out of there, and it's even at full voltage going in, I think it's only around 48 volts. So that indicates to me probably that rectifier tube is weak. So if I was going to go forward with this, the first thing I'd want to do is probably either procure another a good rectifier tube, or modify it and put solid state semiconductors in there to replace it. But again, this is not a radio I really was attached to much in the first place, and now that I know its history for being a widowmaker, I have even less interest in it. So I'm going to just sell it as a parts radio, dirt cheap, hopefully locally, and if that doesn't work out, I'll probably strip it for parts and offer, you know, the knobs and shippable items up for sale on eBay. Alright, so I sorry to disappoint you guys. In case you came along to see this radio actually operating, that's not happening. Take care.